Welcome to my channel Gaming Sim Life and today's podcast, The Infinite Universe. Is there an end to the cosmos? I'm your host Dev, and today we're embarking on a mind-bending journey through space, time, and the very fabric of reality. As you gaze up at the night sky, dotted with countless stars and the faint glow of distant galaxies, have you ever wondered, does the universe go on forever, or is there a boundary beyond which nothing exists? This question has captivated human imagination for millennia, challenging our understanding of existence itself. The concept of infinity in the universe is one of the most profound and perplexing ideas in both science and philosophy. Today, we'll explore whether the cosmos is truly infinite, delve into theories about the shape and structure of the universe, and even touch on the tantalizing possibility of multiple universes. Our purpose in this episode is to embark on a journey to explore the mysteries of the infinite universe, examining scientific theories, philosophical implications, and ultimately tackle the question, does the universe have an end? So, fasten your seatbelts and prepare for a cosmic adventure that will challenge your perceptions and expand your mind. Let's begin by understanding what we mean when we talk about infinity in the universe. In mathematical terms, infinity represents a quantity without bound or end. It's a concept that's easy to write down, that familiar sideways figure-8 symbol, but incredibly challenging to truly comprehend. When we apply this idea to the physical universe, we're asking whether space extends endlessly in all directions, whether there's a limitless amount of matter and energy, and whether time stretches back infinitely into the past and forward into the future. The concept of infinity challenges our understanding of space, time, and existence in profound ways. Our brains, evolved to deal with the finite world of our immediate surroundings, struggle to grasp the idea of something without limits or end. Yet, the notion of infinity has been a part of human thought for thousands of years. Ancient civilizations grappled with the concept of an infinite universe in various ways. The ancient Greeks, for instance, had differing views. Aristotle believed in a finite universe, with the Earth at its center, surrounded by concentric celestial spheres. On the other hand, philosophers like Democritus proposed an infinite universe filled with countless worlds. In India, ancient Hindu cosmology presented a cyclical universe, infinite in time if not in space, with endless cycles of creation and destruction. This idea resonates with some modern cosmological theories, as we'll discuss later. The concept of an infinite universe has evolved significantly over time. The scientific revolution of the 16th and 17th centuries began to challenge the old Earth-centered model of the cosmos. Copernicus placed the sun at the center of our solar system, and Giordano Bruno went further, suggesting that the universe was infinite, filled with countless stars and worlds. Modern scientific inquiry has dramatically reshaped our understanding of the cosmos. The field of cosmology, which studies the origin and evolution of the universe as a whole, has made tremendous strides in the past century. Two figures who have profoundly influenced our understanding of the cosmos are Albert Einstein and Edwin Hubble. Einstein's theory of general relativity, published in 1915, provided a new framework for understanding gravity, space, and time. His equations suggested that the universe could be dynamic, expanding, or contracting, rather than static. Initially, Einstein himself was uncomfortable with this implication and added a cosmological constant to his equations to keep the universe static. However, observational evidence would soon prove that the universe is indeed expanding. Enter Edwin Hubble. In the 1920s, Hubble made groundbreaking observations using the most powerful telescope of his time. He discovered that distant galaxies were moving away from us, and the farther away they were, the faster they seemed to be receding. This led to the formulation of Hubble's law and provided strong evidence for an expanding universe. These discoveries laid the foundation for the Big Bang theory, proposed by Georges Lemaitre and later developed by others. This theory suggests that the universe began as an incredibly hot, dense point and has been expanding and cooling ever since. Now that we've laid this groundwork, let's delve deeper into what we know about the size and shape of the universe. We'll start with a concept that's crucial to our understanding: the observable universe. The observable universe refers to all the space and its contents that we can theoretically observe from Earth, given the limitations imposed by the speed of light and the age of the universe. It's a sphere centered on Earth with a radius of about 46 billion light-years. You might wonder why it's not 13.8 billion light-years if that's the age of the universe. The reason is that space itself has been expanding as light travels through it, allowing us to see farther than we otherwise would. The edge of the observable universe is called the cosmic horizon. Beyond this point, light hasn't had time to reach us since the beginning of the universe. It's important to note that this doesn't necessarily represent the edge of the entire universe. It's simply the limit of what we can observe. Now, let's talk about the shape of the universe, a concept that might seem strange at first. How can the universe as a whole have a shape? When cosmologists discuss the shape of the universe, they're referring to its geometry on a cosmic scale. There are three main possibilities: open, closed, or flat. An open universe is one that expands forever. In this scenario, the universe has a hyperbolic geometry, often likened to the shape of a saddle. An open universe would be infinite in size and would continue expanding at an ever-increasing rate. A closed universe, on the other hand, is finite but has no boundary. It's often compared to the surface of a sphere. If you travel far enough in any direction on the surface of a sphere, you'll eventually return to your starting point. Similarly, in a closed universe, if you could travel far enough in one direction, you would theoretically return to where you started. This type of universe would eventually stop expanding and start contracting, leading to what cosmologists call a big crunch. The third possibility is a flat universe. Current observations strongly suggest that we live in a flat universe. In a flat universe, parallel lines remain parallel forever, and the angles of a triangle add up to 180 degrees, just like in the geometry we learned in school. A flat universe could be finite or infinite in size, and it would continue expanding forever, but at a constantly decreasing rate. The geometry of the universe is intimately linked to its density. If the density of the universe is above a critical value, the universe is closed. If it's below this value, the universe is open. If it's exactly at the critical density, the universe is flat. Current measurements indicate that the density of the universe is incredibly close to this critical value, suggesting a flat universe. These geometric properties of the universe are closely tied to the Big Bang theory and the expansion of the universe. The shape of the universe was likely determined in its earliest moments during a period of rapid expansion called inflation. This inflationary period would have smoothed out any initial curvature, leading to the nearly flat universe we observe today. One of the key pieces of evidence we use to study the shape of the universe is the cosmic microwave background radiation. This is the afterglow of the Big Bang, the oldest light in the universe that we can detect. By studying the patterns in this radiation, scientists can infer the geometry of the universe. The observed patterns are consistent with a flat universe, although there's still some uncertainty in these measurements. Now, let's venture into even more mind-bending territory: the possibility of multiple universes. The concept of the multiverse, the idea that our universe is just one of many, has gained traction in recent decades. While it remains a hypothesis and is not yet supported by observational evidence, it's a fascinating idea that expands our notion of infinity even further. There are several types of multiverse theories, each with its own implications for the nature of reality. Let's explore a few of these. First, there's the concept of bubble universes. This idea comes from a theory of the early universe called eternal inflation. According to this theory, the inflationary period that occurred just after the Big Bang never entirely stopped. While inflation ended in our observable universe, allowing galaxies and stars to form, it continues in other regions. These regions of continuing inflation occasionally spawn new universes, like bubbles forming in a cosmic foam. Each of these bubble universes could have its own physical laws and constants. Then there's the idea of parallel universes, which suggests that multiple universes might exist alongside our own, possibly in higher dimensions that we can't directly observe. These universes might have different physical laws or might represent different possible outcomes of events in our own universe. This leads us to another intriguing concept: the quantum multiverse. This idea arises from an interpretation of quantum mechanics called the many worlds interpretation. According to this view, Every time a quantum event occurs that could have multiple outcomes, the universe splits into multiple universes, each representing a different outcome. If this interpretation is correct, there would be an unimaginably vast, perhaps infinite number of parallel realities. The concept of multiple universes challenges and expands our understanding of infinity in profound ways. If the multiverse theories are correct, what we've been calling the universe is just a tiny part of a much larger, possibly infinite reality. The implications are staggering. It would mean that not only might space and time extend infinitely, but the very possibilities of existence could be infinite. Consider this. In an infinite multiverse, every possible configuration of matter and energy would not only exist but would exist an infinite number of times. There would be countless versions of Earth, countless versions of you, living out every possible variation of your life. It's a concept that stretches the imagination to its limits and beyond. However, it's important to note that while these ideas are fascinating and have some basis in our current understanding of physics, they remain speculative. The multiverse hypothesis is not currently testable, which places it in a gray area between science and philosophy. Nevertheless, it provides a rich ground for theoretical exploration and continues to inspire both scientists and science fiction writers alike. Now, let's turn our attention to a sobering topic: theories about the end of the universe. Even if the universe is infinite in space, could it be finite in time? What might the ultimate fate of the cosmos be? One possibility is the Big Crunch. This scenario is essentially the Big Bang in reverse. If the universe contains enough matter, its own gravity could eventually halt its expansion and cause it to collapse back in on itself. All matter would be compressed into an infinitely dense point, similar to the state of the universe before the Big Bang. Some theorists speculate that this could lead to another Big Bang, creating a new universe and possibly starting the cycle all over again. However, current observations suggest that the universe is not only expanding but accelerating in its expansion. This leads us to another possible fate: the Big Freeze, also known as the heat death of the universe. In this scenario, the universe continues to expand forever. Over unimaginably long timescales, stars would burn out, black holes would evaporate, and the universe would become increasingly sparse and cold. Eventually, even atoms would be torn apart by the relentless expansion, leaving a vast, dark, nearly empty cosmos. A more extreme version of this is called the Big Rip. This theory suggests that the mysterious force causing the universe's acceleration, known as dark energy, could become so strong that it overcomes all other forces. In this scenario, galaxies, stars, planets, and eventually even atoms and subatomic particles would be torn apart by the expansion of space itself. There's also the idea of a cyclic universe, which proposes that the universe goes through endless cycles of Big Bangs and Big Crunches. This concept, reminiscent of some ancient cosmologies, suggests an infinite series of universes, each giving birth to the next. These theories about the end of the universe raise profound philosophical questions. If the universe does have an end, what does that mean for the concept of infinity? Can something be infinite if it has an endpoint? And what would it mean for existence itself if the universe were to end? These questions bring us to the philosophical and theological perspectives on the infinite universe. Philosophers have grappled with the concept of infinity for thousands of years, often finding it paradoxical and challenging to our intuitions. One famous example is Zeno's paradoxes, proposed by the ancient Greek philosopher Zeno of Elea. One of these paradoxes, known as the dichotomy paradox, goes like this: before you can walk the full distance to a destination, you must walk half the distance. Before you can walk half the distance, you must walk a quarter of the distance. Before a quarter, an eighth, and so on infinitely. Therefore, motion is impossible because you'd have to complete an infinite number of tasks. While we know from experience that motion is indeed possible, this paradox highlights the puzzling nature of infinity when applied to the physical world. The idea of an eternal universe, one without beginning or end, has also been a subject of philosophical debate. Immanuel Kant argued that both the idea of the universe having a beginning in time and the idea of it existing for an infinite time led to contradictions. This antinomy, or apparent contradiction in reason, highlights the difficulty our minds have in grappling with cosmic timescales and infinity. Religious and theological perspectives on the infinite universe vary widely. Many religious traditions include the concept of an infinite or eternal deity, which in some ways parallels the concept of an infinite universe. However, many religious cosmologies describe a created universe with a definite beginning, which may or may not have an end. For example, the Judeo-Christian tradition generally describes a universe created by God at a specific point, with some interpretations including an end times or final judgment. Islamic cosmology similarly includes a created universe, with the Quran describing Allah as the originator of the heavens and the earth. Hindu cosmology, as mentioned earlier, presents a cyclical view of the universe, with cycles of creation and destruction repeating over vast timescales. This view has some interesting parallels with scientific theories of an oscillating universe. Buddhist cosmology often describes multiple world systems and realms of existence, in some ways reminiscent of multiverse theories. However, these are typically viewed more as states of being rather than physical realities. It's worth noting that many people find ways to reconcile their religious beliefs with scientific cosmology, viewing scientific discoveries as revealing the mechanisms through which a divine plan unfolds. The concept of an infinite universe, or even just the vast scales involved in our observable universe, can have profound psychological and existential implications. Contemplating the possibly infinite expanse of space and time can evoke a range of emotions and thoughts. For some, the idea of an infinite universe is awe-inspiring and uplifting. It can provoke a sense of wonder at the vastness and complexity of existence. This feeling, sometimes called the overview effect, when experienced by astronauts viewing Earth from space, can lead to a sense of cosmic connectedness and a reevaluation of what's truly important in life. For others, the concept of infinity can be overwhelming or even frightening. It can trigger what's sometimes called cosmic anxiety, a feeling of insignificance in the face of the universe's immensity. This reaction is beautifully captured in Blaise Pascal's famous quote, "The eternal silence of these infinite spaces frightens me." The possibility of an infinite universe also raises intriguing questions about the nature of existence and our place in it. If the universe is truly infinite, does that mean that everything that can happen will happen an infinite number of times? What does that imply about the uniqueness of our existence or the nature of free will? These questions bring us to the cutting edge of cosmology and the search for answers. Current research in this field is nothing short of extraordinary, pushing the boundaries of our understanding and our technological capabilities. One of the most exciting areas of research involves mapping the large-scale structure of the universe. Projects like the Sloan Digital Sky Survey have created three-dimensional maps of large portions of the sky, revealing a cosmic web of galaxies clustered along filaments with vast voids between them. These maps help us understand how matter is distributed in the universe and provide clues about its overall structure and evolution. Another crucial area of study is cosmic inflation, the theory that the universe underwent a period of rapid expansion in its earliest moments. Researchers are searching for evidence of gravitational waves that would have been produced during this inflationary period. Detection of these waves would not only confirm the inflation theory, but could also provide insights into the earliest instance of the universe's existence. Dark energy, the mysterious force causing the universe's accelerating expansion, is another major focus of current research. Scientists are working to understand the nature of dark energy, which could hold the key to the universe's ultimate fate. Technological advances play a crucial role in these investigations. Next-generation telescopes, both on Earth and in space, promise to push our observations to new limits. For example, the James Webb Space Telescope, launched in 2021, is designed to look further back in time than ever before, potentially glimpsing the first galaxies formed after the Big Bang. Gravitational wave detectors like LIGO, Laser Interferometer Gravitational Wave Observatory, have opened up an entirely new way of observing the universe. By detecting ripples in space-time caused by massive cosmic events, these instruments allow us to hear the universe in a way never before possible. Despite these advancements, many questions remain unanswered. We still don't know for certain whether the universe is infinite or finite. We don't fully understand the nature of dark matter and dark energy, which together make up about 95% of the universe's content. The possibility of a multiverse remains speculative, as does our understanding of what, if anything, existed before the Big Bang. As we conclude our cosmic journey, let's recap the key points we've explored. We've delved into the concept of infinity and how it applies to the universe, examined theories about the size and shape of the cosmos, and explored the mind-bending possibility of multiple universes. We've contemplated the potential end of the universe and considered philosophical and theological perspectives on these grand questions. We've seen how our understanding of the cosmos has evolved over time, from ancient mythologies to the cutting-edge theories of modern cosmology. We've marveled at the technological advancements that allow us to peer deeper into space and time than ever before, and we've acknowledged the many mysteries that still remain. Throughout our exploration, we've encountered ideas that challenge our intuitions and stretch the limits of our imagination. As we conclude, I'd like to leave you with a thought-provoking question. If the universe is infinite, what does that mean for our understanding of existence? And if it's not, what lies beyond its boundaries? These questions remind us of the vastness of the cosmos and the endless frontier of human knowledge. They invite us to continue exploring, questioning, and wondering about our place in this magnificent universe. Whether finite or infinite, our cosmos is a source of endless fascination and discovery. Thank you for joining me on this cosmic journey through the infinite universe. I encourage you to share your thoughts, theories, and questions in the comments below. Keep looking up, keep wondering, and keep exploring the mysteries of our extraordinary universe. Until next time, this is Gaming Sim Life signing off.
right.